Okay, so just to finish off about blue holes, okay, so the level of water in blue hole is often affected by the tides and also by the water table. Alright, so if the water table goes up or down, okay, so for example, if we look at our image here, okay, some of them, the tunnels go all the way out to the ocean. So if the tide goes down, the level of water up here will drop. If the tide comes in, the level goes up. Our water table is shown by our dotted line. So if there's a period without any rain, the water table drops. So does the surface of our blue holes. Alright, so we're just going to skip on. We're almost finished with Rocklands now. On page 80, a little bit just about blue holes and the level of life. Alright, so they have some life in them, but not very much, depending on food available. Alright, so leaves and other vegetable matter can get into the holes and supports very few small fish. Even the ones in oceans, or the ocean holes, okay, they equally produce very little food. So first things first, there's very little light in blue holes. There can be a lack of oxygen in the water, and there's very, very little food in there. So you won't actually find that much life in blue holes, alright? Okay, last little bit about blue holes then as well. Okay, the water in many blue holes is fresh at the surface. As we know about the water table, it becomes brackish and then saline. Okay, so it gets more salty the deeper down you go. Very simple. To finish off Rocklands, okay, limestone crust. So it gets this crust. Think of the crust on a loaf of bread or a bread loaf. Right, it's harder than everything else and it covers it. So this limestone crust is usually a reddish or white color or reddish. All right, and various thicknesses, but usually very thin. One key thing is it's much harder than the limestone it covers, so it's like this crust over the limestone rocklands. Okay, two things we do know: crusts are only found in the tropics, so we suggest it's something to do with their climate. Okay, and they're only found on land. When they're introduced or close to the sea, they erode rapidly, so therefore they are formed on land. Our limestone is formed under the sea, and that's why the water can affect it so much. This crust seems to be formed on land, and why it also gets affected by water so much. Alright, so it's not born out of the same place as the limestone. And on to page 83. Okay, the red colouring is now known to be derived from the dust blown across the Atlantic Ocean from the Sahara Desert. Alright, so it might sound a bit crazy, but actually every year a lot of soil and sand blows off the Sahara Desert and across the Atlantic into the Caribbean and northern South America. Okay, and it is also quite a reddish yellowy colour. It appears from all the evidence, right, that the crust forms after rain dissolves some of the limestone, and then deposits of this red soil are put in a layer containing various impurities when the rainwater is evaporated at the surface. So the surface of the limestone is eroded away. This soil then comes along and settles in the kind of wet mixture, and as the water evaporates away, it's left behind to create this hard shell or hard surface. Alright, so that is your limestone crust. That's the last feature of our rocklands. I'm going to draw two quick diagrams, okay, on video of our blue holes, just to go back and explain them a little bit further. Okay, so under where you've headed up and done your notes from the first video, we're going to draw two sketches of blue holes, okay, and we'll label them fully. So I'll be back to you in a second. Okay, so what we're going to do is, I have my whiteboard here. I'm going to sketch out how blue holes can form. I've written up in the corner, blue holes form or formation. Okay, so what we're going to start off with is a nice, you can do this the width of a page, with half a page of folder sheet. Okay, we're going to start off with our seabed coming up like this, and here we are. Over here I'm going to write down land surface, and as always, little stick person, that can be you. Okay, now what we have is a couple of different things. I'm going to jump over to a blue marker. Okay, what I'm going to put down as, I'm going to put down here our present day sea level, and then a dotted line. Okay, so present sea level, and then also WT over there for water table. Okay, just below. So you should be able to see that's just below there. Down the very bottom, I'm going to have another blue line and another dotted blue line. Okay, ice age water table, ice age ocean level. Okay, so what happened was, as you can see at the moment, if the ocean level had stayed like it is now, only the very top of the land is exposed. Okay, so I'll do my notes in green. Alright, so you can show that this bit is exposed to erosion or weathering. Okay, so I've written exposed to erosion up there. Alright, now when the sea levels dropped in the ice age, okay, drop in sea level, okay, what began to happen is more of the limestone became exposed. Now when you've got your sea level or water table here, any water that gets into the limestone, it fills up the water table, no erosion occurs. But when this sea level drops down, erosion can occur all the way in here. Now we know what happens, okay, to our limestone landscape. So what we start to get is our sinkholes coming down and making caves and the water flowing. Okay, so you're left behind with systems like this, okay, or even bigger ones where this could come all the way down and out. Okay, so this could have come down and had a cave, and then it could have come down like this. Okay, so lots of different things or cave systems would have occurred. Okay, so I'll just write cave, 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 all the while the sea level was so low. Alright, remember, water will always try and find the quickest route. If I draw little arrows of water coming out here. Okay, now we know this because we've found stalagmites, alright, hanging down, or stalactites and so on in some blue holes. That illustrates that at some point these were empty. There was no water, sorry, they weren't full of water, and the water was actually flowing through them. Okay, so that is what happened. Now in the opposite then, after the ice age, after ice age, sea level rises, okay, to where it is presently. So now all of these are full, they're flooded with water. Okay, all of them are filled up, but when we stand at the top, we're looking down into a blue hole. Okay, now we said that the ice age dropped, the water during the ice age dropped about 122 meters. All of our blue holes in the Bahamas except Dean's Blue Hole are less than that deep. Okay, so that's how we know this happened. Alright, so again, one other thing then, I just want to add one other excuse me, little label. Alright, below sea level, so tides control surface of blue holes. Okay, now we don't have enough time to do another one for Dean's Blue Hole. I might add another video if I get a bit of time, or else I'll just send you a little image of a sketch at the start of the next lesson. Okay, but I do want you to have a go and try to do something like this. So let me just see if I can get that picture in. Okay, so you've got exposed to erosion, land surfaces below sea level, so tide controls surface of blue holes. Ice age, WT stands for water table, and over here. Okay.